Picture yourself hanging above Saturn's north pole, where the sunlight is thin and the clouds look carved with a blade. Saturn's hexagon is the quiet shape at the center of this story, because if a planet can grow a six-sided wind pattern and keep it for decades, then our idea of what weather is has to widen fast. Subscribe for calm, deep space stories that make the next headline mean more when you hear it. Far below you, the clouds do something clouds are not supposed to do. They do not curl into a spiral or break into chaos. They bend, turn, and meet again in six long sides, as if a storm learned geometry. And somewhere else, on a bigger world, a red oval the size of a planet has been glaring back at human beings for generations. Most people think they already know which one wins this contest. Jupiter's great red spot is louder, older sounding, and easy to love. It looks like a cosmic bruise, a wound, an eye, a storm big enough to swallow Earth. Saturn's hexagon, by comparison, can seem like a neat trick you mention once and move on from. But strangeness is not always the thing that shouts the hardest. Sometimes it is the thing that stays still when it should break apart. Sometimes it is the shape that should not survive, the pattern that keeps returning, the quiet detail that starts to bend the whole story around itself. And that is where this comparison stops being obvious. To see why this matters, we need to step back. Most people believe Jupiter's great red spot is clearly the stranger one. It is the famous monster storm, while Saturn's hexagon is just an unusual pattern near a pole. That belief feels so natural that, at first, it barely seems worth testing. Jupiter earns that first impression honestly. Even through a small backyard telescope, it looks alive. Its cloud bands slide past each other like cream stirred into coffee, and then, there on the southern side, sits the red mark people remember long after they forget every moon. It has the kind of presence that turns a science lesson into a myth. The Great Red Spot is not a crater, not a mountain, and not a solid thing at all. It is a storm, a giant, long-lived swirl in Jupiter's air. The winds race around its edge far faster than anything a person has ever felt on Earth. When people hear that, the mind does the rest and starts building a legend. For a long time, that legend sounded almost too large to doubt. Many people grew up hearing that the spot had raged for hundreds of years, maybe since the age of the earliest telescopes. It was described as a storm so ancient that whole human empires had risen and fallen while it kept turning. A red engine on a world with no ground beneath it. The numbers only made the feeling stronger. Historic measurements in the late 19th century put its long size at about 25,500 miles, more than enough room to fit Earth more than once across. When Voyager 1 and Voyager 2 passed Jupiter in 1979, the spot was still about 14,500 miles wide. Even after decades of shrinkage, it remained planet-sized in the public imagination. In May 2014, Amy Simon at NASA's Goddard Space Flight Center said Hubble had confirmed the Great Red Spot was down to about 10,250 miles across. That was the smallest diameter ever measured at the time. She also noted that amateur astronomers had seen the shrinking speed up around 2012. Even while getting smaller, the storm felt dramatic, like a giant beast growing lean but not weak. That shrinking did not make it feel less strange. If anything, it made the storm feel alive in a new way. People could imagine watching a famous landmark change shape in real time, like seeing the Grand Canyon narrow or the Pacific Ocean breathe in. A thing that big was not supposed to have a waistline. Then there was the color. Red is powerful in the mind. A storm in beige or white would still be huge, but it would not lodge in memory the same way. The Great Red Spot carries its own branding, as if Jupiter signed its weather with a marker the whole solar system can read. Scientists wanted to know why it was red at all. Kevin Baines of NASA's Jet Propulsion Laboratory and colleagues used Cassini flyby data and lab tests to argue that the color is likely a kind of chemical sunburn. In simple terms, sunlight breaks apart gases like ammonia and acetylene high in Jupiter's atmosphere and helps make a reddish material at the top. That explanation is wonderfully weird, but it still sounds like weather chemistry, only larger and rougher. The deeper scientists looked, the more the storm rewarded attention. During a July 2017 pass, NASA's Juno spacecraft flew over the Great Red Spot and used a microwave instrument to peer below the top clouds. Scott Bolton of the Southwest Research Institute said the storm's roots reach about 200 miles or 300 kilometers down. Andy Ingersoll of Caltech said the base is warmer than the top, and those temperature differences help drive the fierce winds. That detail matters because it makes the storm feel physical, not a painted swirl on the surface, but a deep structure with weight and reach. Michael Jansen at JPL said Juno's microwave radiometer could finally help scientists get to the bottom of what makes the Great Red Spot so great. The phrase sounds almost playful, but the idea is serious. This storm has depth. So if you were making a quick list of the strangest weather in the solar system, Jupiter almost writes the answer for you. A giant red storm, a history wrapped in telescope lore. Winds faster than Earth's worst cyclones, and a body that sinks hundreds of kilometers into a world made mostly of gas. It feels like the obvious champion. Saturn, meanwhile, enters the story much more quietly. Its colors are softer. Its clouds often look gentler from far away, like pale bands brushed with smoke. Even when people learn Saturn has a hexagon at its north pole, the fact can slide past them because the word sounds almost too neat to be real. And yet the hexagon is not a small doodle at the edge of the planet. NASA describes it as a huge jet stream around Saturn's north pole, roughly 20,000 miles or 30,000 kilometers across. The winds move at about 300 miles per hour, around 500 kilometers per hour. That is not a cute shape on a poster. It is a continent-sized pattern in motion. Still, the first emotional reaction is often weaker. The Great Red Spot looks like danger. The hexagon looks like design. One feels wild. The other can feel almost decorative, the way a snowflake looks less frightening than a thunderstorm, even though both come from physics. So the mind keeps leaning back toward Jupiter. The history of attention pushes the same way. People had been staring at Jupiter for centuries. Children learn the Great Red Spot early, sometimes before they learn the names of Saturn's moons. By contrast, Saturn's hexagon was only noticed when Voyager spacecraft passed in 1980 and 1981, and even then the views were incomplete. It arrived later, dimmer, and with less myth already built around it. That matters more than we admit. The thing we have known longest often feels deepest. The thing that entered our lives first often feels most important. So by the time our comparison begins, Jupiter already seems to have won on fame, scale, age, and raw force. The Great Red Spot appears to be the stranger object by almost every normal measure. If you stopped here, you could defend that answer all day. You could point to its red color, its enormous width, its long watch through history, and the simple fact that it still exists at all. You could say Saturn's hexagon is interesting, yes, but only as a side note to the real giant of planetary weather. And for a while, that is exactly how the story looks. But that picture is about to change. The closer scientists looked, the more Jupiter's storm began to feel like an extreme version of weather we already recognize, while Saturn's shape began to act like something from a rule book we had never read. The surprise is not that the Great Red Spot became ordinary. The surprise is that the hexagon kept becoming less ordinary every time the evidence improved. Write the exact moment your guess started to wobble in the comments. That one note helps shape which hidden space mystery we unpack next. Because once the obvious answer cracks, you start watching every new detail with different eyes. And that is exactly where the real comparison begins. Start with the kind of shape weather usually makes. On Earth, storms spin, break, merge, stretch, and dissolve. Jet streams wiggle like loose ribbons on a windy day. So when Voyager first caught glimpses of a six-sided feature around Saturn's North Pole in 1980 and 1981, the expectation was simple. This would turn out to be a temporary accident. What was actually found was harder to file away. The pattern did not look like six random corners in messy clouds. It looked organized, broad, and stubborn, a real structure wrapped around the pole. It was like walking into a forest and finding the wind had trimmed a clearing into a near-perfect shape with straight sides longer than nations. Even then, there was room to downplay it. Voyager did not get a clean, top-down view of the whole thing. The spacecraft flew past at angles that showed only parts of the edge. A skeptic could still say the human brain was doing what it loves to do, finding order where there was only noise. For a while, that kept the hexagon half hidden inside uncertainty. Then Saturn's long seasons slowed everything down. A Saturn year takes about 29 Earth years, so each season lasts more than 7 Earth years. When Cassini arrived in 2004, the North was deep in winter darkness. If the hexagon were a short-lived pattern, scientists might have expected it to fade before sunlight returned. Instead, it waited there in the dark. Cassini used its visual and infrared mapping spectrometer in 2006 to see the hexagon by heat, not visible light. That is important because it means the shape was not just a trick of sunshine and shadow. The expectation was that darkness would hide the story. What scientists found was that the story was still speaking, only in infrared, like seeing the outline of a city by the warmth of its streets at night. When spring finally reached Saturn's north around the 2009 equinox, Cassini's main cameras got their chance. What they saw was almost rude in its clarity. A jet stream about 30,000 kilometers across, with winds near 500 kilometers per hour, tracing a remarkably symmetric hexagon around the pole. Not a vague wobble, not a rough polygon, a six-sided pattern big enough to mock your sense of scale. Kevin Baines at JPL called it one of the biggest mysteries of Saturn's dynamics, which is a formal way of saying the planet was doing something deeply strange. At the center sat a tight vortex, a hurricane-like whirl with an eye about 50 times larger than the eye of a typical Earth hurricane. The expectation was a dramatic pole. The reality was a dramatic pole wrapped inside a geometric frame, like finding a cyclone parked in the middle of a stop sign. Now compare that to Jupiter's Great Red Spot with fresh eyes. The red spot is huge, yes, and violent, yes, but it is still a storm shaped like a storm, an oval made by flowing gas and bounded by nearby jet streams. The more scientists learned about it, the more it began to sound like a supersized cousin of patterns fluid physics already knows how to grow. That does not make Jupiter boring. Far from it. When Juno flew over the Great Red Spot in July 2017, scientists expected depth, but not endless depth. What they found was a storm reaching about 300 kilometers down, deep yet still shallow compared with Jupiter itself. It was like learning that a mountain of cloud has roots, but not roots that run through the whole planet. That result made the Great Red Spot easier to place. A giant anticyclone, which means a massive high-pressure swirl, trapped between strong jet streams. Amy Simon's work with Hubble and Mike Wong's later description of the spot being squeezed by fast winds to the north and south gave that picture even more shape. Expected? A totally unbound monster. Found? A storm held in a lane, like traffic forced between walls. In that sense, the red spot started becoming more understandable as the data improved. Still astonishing, still beautiful, still larger than Earth, but understandable. Its redness likely comes from chemistry near the top. Its changing size can be tracked. Its motion can be timed. A mystery, yes, but one that keeps letting science get a hand around its shoulder. Saturn's hexagon did something more unsettling. The better the images got, the less it behaved like a simple curiosity. Andrew Ingersoll of Caltech pointed out that weather features like this are usually turbulent and unstable. A hurricane on Earth might last a week. The expectation then was that a shape this clean would smear out quickly. But the hexagon did not smear. It survived from Voyager in the early 1980s to Cassini decades later. It stayed coherent through seasons that each outlast a school career. It was like drawing a shape in steam and coming back years later to find the steam still holding the line. That kind of persistence feels wrong in the best possible way. Scientists tried to explain it with a Rossby wave, which is a giant wobble in a fast jet stream caused by a rotating planet. A 1990 science paper by Mark Allison and colleagues argued that the hexagon could be this kind of standing wave. That was a smart and powerful idea. Expected, chaos. Found, a wave pattern stable enough to look almost engineered. And yet even that explanation left loose ends everywhere. Why only the North Pole and not the South? Why 6 sides instead of 5 or 8? Why does the shape remain so long-lived when similar-looking flows on Earth refuse to sit still? Each answer solved one corner and opened 2 more, like patching a roof only to hear rain in a different room. The comparison grows sharper here. Jupiter's Great Red Spot is shocking in scale. Saturn's hexagon is shocking in form. One says, look how huge a storm can become. The other says, look how far order can go in a place built from moving gas. Size hits the chest. Geometry gets under the skin. Cassini kept pressing. In late 2012, it began making higher swings over Saturn's poles and delivered the best views yet of the hexagon. Scientists saw smaller vortices caught in the jet stream, like leaves riding a circular canal. One large vortex inside the hexagonal boundary spanned about 2,200 miles, around twice the size of the largest hurricane ever seen on Earth. The expectation was that detail would make the shape look messier. Instead, detail made the system feel even more deliberate. Then another surprise arrived through color. As Saturn moved from spring toward its northern summer, the inside of the hexagon changed appearance. NASA notes that a bluish look seen in 2013 shifted toward a yellow haze by the time of Saturn's summer solstice on May 24, 2017. Expected, a fixed symbol. Found, a living seasonal machine, like a famous building changing color with the weather while keeping every wall in place. Researchers think sunlight was breaking apart methane and helping form haze particles, something like smog chemistry on a planet with no streets. That is already a strange sentence, but the stranger part is where the haze gathered. Small particles filled the inside of the hexagon, while larger ones were more common outside, with the jet stream acting as a kind of border. It was as if the shape was not just being traced by wind, it was sorting the sky. Meanwhile, Jupiter kept yielding secrets that, again, made it richer but also more classifiable. Kevin Baines and colleagues argued the Great Red Spot's red color is mostly a top coating made by sunlight acting on gases high up. Amy Simon's Hubble work showed long-term shrinking. Later, in 2024, Hubble watched the red spot jiggle over a 90-day cycle from December 2023 to March 2024. Expected, a fixed red eye. Found, a wobbling storm, more like gelatin in a bowl than a painted badge. That 2024 result was wonderful. Simon said the spot was squeezing in and out while speeding up and slowing down, something not identified before. Mike Wong of the University of California, Berkeley, compared it to a sandwich bulging when the filling is pressed from both sides. The Great Red Spot stayed weird, but in a familiar fluid way. Pressure, motion, squeeze, release. Our brains know how to picture that. Saturn refused to stay in that same box. In September 2018, a paper in Nature Communications, led by Lee Fletcher of the University of Leicester, changed the argument again. Using Cassini data, the team reported a warming vortex in Saturn's stratosphere, the layer above the main weather deck, with edges that appeared hexagonal too. Expected, one hexagon in the clouds. Found, a matching hexagon hundreds of miles higher. That is the kind of result that makes you stop reading and start reading again. A storm shape at one level is already odd. A corresponding hexagonal pattern in the stratosphere suggests the lower feature may influence layers far above, almost like a tower of weather rising through the atmosphere. Not a doodle on Saturn's surface, but a structure with vertical reach, like hearing the same note played in the basement and the attic at once. NASA's JPL said this could mean the lower altitude hexagon is a towering structure hundreds of miles high. Fletcher put it plainly. The edges of the newly found vortex looked hexagonal, precisely matching the bizarre cloud pattern below. The expectation had been a local trick of winds. The finding felt more like a planetary habit, as if Saturn knew the shape so well it repeated it across layers. And still the question stayed alive. Scientists do not fully agree on exactly how deep the hexagon's controlling jet goes, or how the pattern locks itself so neatly in place. The NASA summary points to 2020 Harvard work suggesting a deep supersonic jet stream may be pinched by smaller cyclones and pushed upward. Helpful, yes. Final, no. This is the point in the story where uncertainty adds trust instead of taking it away. Ravi Kumar Yadav and Jeremy Bloxham at Harvard used a 3D model to explore how deep convection, meaning rising and sinking flows inside the planet, could help generate the polar hexagon. That gives the mind a route toward explanation. But a route is not the same as arrival. We still do not know why Saturn's North Pole made this shape and its South Pole did not, which is exactly the kind of unfinished edge that keeps the hexagon stranger than a solved puzzle. The Great Red Spot has unfinished edges too, of course. A 2024 Geophysical Research Letters study led by Agustin Sanchez La Vega argued that the modern red spot may be about 190 years old, not the same feature people saw in the 1600s. That matters because it gently reduces one of the storm's oldest myths. Expected, one immortal storm across centuries. Found, maybe a younger storm wearing an older legend like a hand-me-down coat. Even that change, though, pulls Jupiter toward the understandable. Its old mystery gets cleaned up by better history. Its color gets narrowed by chemistry. Its depth gets measured. Its shape oscillation gets tracked. Every answer keeps it grand, but also keeps it inside the family of giant storms. The hexagon keeps escaping that family. It is not merely large. It is not merely long-lived. It is a moving current of air that behaves with the visual discipline of architecture and the stubbornness of climate. It is the kind of thing that would feel artificial if we found it in a science fiction film, and yet there it is in raw spacecraft data. So which is stranger? If strange means more violent, more famous, or more immediately dramatic, Jupiter's Great Red Spot wins with ease. But if strange means further from our normal idea of what weather is allowed to do, the balance shifts. A red oval storm is a storm turned up to impossible size. a six-sided jet stream that persists for decades and echoes upward into another atmospheric layer, is weather stepping into geometry. That is the crucial turn. Jupiter shocks us by scale. Saturn shocks us by behavior. And behavior is the deeper kind of weird, because it does not just impress the eye. It bends the rules you thought nature preferred, the way a calm voice can be more unsettling than a scream when it says something that should not be true. Send this to the friend who thinks space gets less surprising once you learn the names. Sharing it with one quiet skeptic is the fastest way to start a real conversation, not just trade facts. Because here is where the story stops being about one storm and one jet stream and starts being about how easily the universe outruns our first guess. And that matters far beyond Jupiter and Saturn. If the hexagon is the stranger object, the lesson is not that Jupiter became ordinary. The lesson is that familiarity can fool us. We are drawn to violence, color, and size because they read quickly. But some of the deepest surprises hide inside persistence, pattern, and form. The universe does not always wave for attention. Sometimes it waits for patience. That changes how we think about weather on other worlds. When astronomers look at giant planets, or even at planets around other stars, they are not just asking whether there are storms. They are asking what kinds of order can grow inside moving gas, how long that order can last, and whether an atmosphere can build structures that feel halfway between climate and design. Saturn's hexagon makes those questions feel less abstract and more urgent. It also changes how we think about our own planet. Earth's atmosphere is shallow compared with Saturn's, full of mountains, oceans, ice, forests, and day-night swings that constantly disturb the flow. Our weather is messy because our home is textured. Saturn, by contrast, is more uniform at the top, more open to large, sweeping patterns. The comparison is like watching ripples in a bathtub versus currents in a vast, rotating tank. That is a domestic anchor worth holding on to. The next time you watch steam curl over a pot, or cream spread in coffee, or wind push leaves into a shape for half a second before it breaks, remember that Saturn found a way to keep a shape. Not for seconds, not for minutes, for decades that we know of, and perhaps much longer. A kitchen swirl becomes a door into planetary physics. Future missions will not ignore that door. Jupiter still has Juno in the story of giant storms, and Hubble still revisits the outer planets through long-term programs like Opal. But Saturn now sits in a frustrating place. Cassini ended on September 15, 2017, diving into the atmosphere to protect potentially habitable moons from contamination. That means the hexagon's future is being watched from farther away, with fewer eyes than it deserves. And yet the data Cassini sent home is still being mined. Linda Spilker of JPL said after the mission that the mystery and extent of the hexagon continue to grow. That line keeps proving true. The spacecraft is gone, but the archive remains, like boxes of film from a city no one can visit right now. Researchers are still opening those boxes and finding weather that does not feel finished. What happens next will come in layers. More careful modeling will test how deep the controlling jet really runs. Laboratory experiments will keep trying to reproduce polygon shapes in rotating fluids, and not just hexagons, but squares and octagons too. At the same time, telescopes will keep watching for seasonal changes in Saturn's north, looking for shifts in haze, color, and temperature. The goal is no longer just to admire the shape, it is to catch the rules that sustain it. Jupiter's Great Red Spot has a different future. Scientists want to know whether the storm will stabilize at a smaller size or continue its long decline. Amy Simon and colleagues have suggested it may keep shrinking before settling into a less elongated shape. That makes the red spot feel like an old giant still changing in public, not frozen in its legend. Its next chapter may be about aging rather than mystery. Saturn's hexagon, by contrast, still guards its central secret. On dates like August 11, 2009, when Saturn crossed equinox, and May 24, 2017, when northern summer solstice arrived, the changing light helped reveal the shape in new ways. The next precise milestones matter because Saturn moves slowly. A decade on Saturn is not a full story, it is a paragraph. That slow clock affects the people studying it. A graduate student might begin work on Saturn's atmosphere and not see a whole seasonal cycle before becoming a professor. A child who watched Cassini's finale in 2017 could be an adult before a dedicated new Saturn orbiter ever arrives. The hexagon asks for a kind of patience modern life rarely trains. It is science by long breath, not quick refresh. Still, the precision is getting better. We can now say the lower hexagon is about 30,000 kilometers across. We can say the jet stream moves at roughly 500 kilometers per hour. We can point to the 2018 Nature Communications result that the stratospheric feature sits hundreds of miles above the clouds. And we can tie the possible deep-driving flows to the 2020 Harvard modeling work. The closer we get to the present, the sharper the numbers become, and the stranger the pattern remains. There are also questions that reach beyond Saturn. Could other gas giants hide stable polygonal jets we have not yet resolved? Could exoplanets, planets around other stars, carry weather structures that would look even less natural to us from a distance? If all we see is a changing glow or a slight shift in heat, would we even know a geometric pattern was there? Saturn teaches caution. Nature may be weirder than our instruments can currently confess, and there is a human side to this that matters just as much. We live in a time when images come fast and attention breaks faster. The Great Red Spot wins instantly because it is easy to grasp. The hexagon asks you to stay. It asks you to care about the shape inside the storm, the pattern inside the pattern, the fact that a planet can spend years quietly doing something no child would draw unless told. It rewards patience the way some books do, only after page 50. That makes Saturn's hexagon feel almost like a test of seeing. Can you notice the quieter wonder? Can you let the less obvious object move to the front once the evidence earns it? Science depends on that kind of shift all the time. The first answer is not always wrong because it is foolish. Sometimes it is wrong because it arrived before the best data did. Watch how the dates stack up now. 1980 and 1981 gave us Voyager's first glimpses. 2004 brought Cassini to Saturn. 2006 let infrared observations hold the shape in winter darkness. August 2009 brought equinox light. December 10th, 2012 delivered some of the best high views. May 24th, 2017 marked northern solar solstice. September 3rd, 2018 brought the stratospheric hexagon paper. By 2020, deep convection models were being tested in detail. Jupiter has its own timeline, just as sharp. May 15, 2014 gave Hubble's famous shrinking measurement. July 2017 gave Juno's close pass over the Great Red Spot. October 9, 2024 brought the report that the storm was jiggling through a 90-day cycle observed from December 2023 to March 2024. June 2024 brought the age study arguing the modern spot may be about 190 years old. Those dates do not shrink the red spot's wonder. They simply place it on a path science can increasingly map. So when you hear future headlines, listen for the kind of weirdness being described. If it is about bigger, deeper, faster, Jupiter will often lead the room. Jupiter's Great Red Spot will keep teaching us how giant storms live, shrink, and wobble on a world far larger than our own. Save this video and come back the next time Jupiter or Saturn makes the news. That one quiet habit will sharpen how you hear the future before the future gets here. Because the image I want you to carry is not the loud red storm everyone knows. It is a pale, six-sided loop around a distant pole, holding its line in air. Imagine it on one exact date, December 10th, 2012. Cassini is above Saturn's north, building a movie from 8 images taken over 10 hours. A spacecraft the size of a small car is watching a weather pattern wider than Earth trace a shape no wind on our planet can keep. That scale difference alone is enough to reset a human mind. And then narrow it even more. One side of the hexagon stretches for thousands of kilometers. Inside it, haze shifts with season. At the center, a polar vortex spins. Hundreds of miles above, the atmosphere may echo the same geometry. No sound reaches you there, but if it did, it would feel less like thunder and more like a steady note that never quite ends. That is why, in the end, Saturn's hexagon is stranger. Not because it is bigger than Jupiter's Great Red Spot in every way, and not because Jupiter stopped being magnificent. It is stranger because it makes the atmosphere itself seem capable of memory, as if the planet has found a way to keep repeating a shape through time. And I think the future will keep proving that the quietest patterns are often the ones worth following longest.